Hi everyone, welcome to KMLS Chemistry channel. In this video, I'll be presenting the first part of Introduction to Organic Chemistry. In my previous chemistry classes, students often asked, why do they need to learn organic chemistry and what are the importance of organic chemistry? The answers to the questions are simple. As the world is changing rapidly, the contribution of organic chemistry to mankind has become tremendous. Organic chemistry-related careers and industries provide the essential services and products which we require for life sustainability. Without the petroleum industries, for example, vehicles will not move, machines will not run, food cannot be cooked, and factories will cease operation, and many people will lose their jobs. This is just one of the examples of how organic chemistry impacted our lives. Without pharmacologists and the pharmaceutical industries, in times when a pandemic hit the entire world like what we are now experiencing, we will not be able to find a vaccine to stop the pandemic. This is just another current example of how important organic chemistry is to our lives. So on this slide, you are able to see all the organic chemistry related industries and fields. Agricultural industries, the petrochemical industries, chemical engineering, polymer industries, the medical field, and many more. To start off with this lesson, my first and foremost question: what is organic chemistry? Basically, organic chemistry is the study of carbon compounds, which extends to the understanding of organic reactions. Besides carbon, elements that are usually found in organic compounds are hydrogen, oxygen, nitrogen, halogen, and sulfur. The term hydrocarbon refers to organic compounds that contain only carbon and hydrogen atoms. Since carbon has 4 valence electrons, each carbon may form 4 covalent bonds. The covalent bonds around an atom in an organic compound may exist in the form of single bond, double bond, or triple bond. For carbon atom, each atom can only have a maximum of 4 bonds, which can either be 4 single bonds, 1 double and 2 single bonds, or 1 triple bond and 1 single bond. For oxygen atom, each atom can only have 2 bonds, which can either be 2 single bonds or 1 double bond. While for nitrogen atom, each can only have 3 bonds, which can either be 3 single bonds or 1 double and 1 single bonds or 1 triple bond. Organic compounds may be categorized as saturated or unsaturated compounds. Saturated compounds contain only single bonds, thus unable to undergo addition reaction. For unsaturated compounds, they may contain double or triple bonds, which allow them to undergo addition reactions. Unlike in organic compounds have three different types of formulas, namely the empirical, molecular, and structural formula. But the key highlight is the structural formula that shows the bonding order of atoms in a molecule. As beginners in learning organic chemistry, students should master the writing of proper structural formula for organic compounds. The structural formula of organic compounds can be written in three forms: expanded structure, condensed structure, and skeletal structure. In an expanded structure, each and every atoms are shown, and every single bond between atoms must also be written. In condensed structure, atoms of the same type are grouped together, and double or triple bonds are usually shown. Skeletal structure is the simplest structure that shows only the carbon skeleton. Atoms or groups such as oxygen, any halogen, nitrogen, or groups such as hydroxyl and etc. are shown. At the beginning, learners would find expanded structure the easiest to master. But the setback is this formula requires longer time to write. Therefore, it is most advisable for students to master the writing of condensed and skeletal structures as well. This is an example of the three different forms of structures for an organic compound with the molecular formula of C5H12. The first is the expanded structure, where each and every atom in the compound is shown and each and every bond is clearly written. Next, the condensed structure. In this structure, repeating hydrogen atoms on the same carbon are grouped together. The last is skeletal structure, where only the carbon skeleton is drawn by using lines or strokes. You may observe more examples on this slide. In condensed structure, repeating groups are sometimes further condensed in bracket with a numeral subscript indicating the number of times the group repeats. Let's take a look at the example of the compound C5H12. There are three repeating CH2 groups, which can further be condensed in bracket. If a compound has two or more similar groups bonded to the same carbon, the group can be written in bracket with a numeral subscript. Let's take a look at this expanded structure of a compound. In this structure, there are three CH3 groups attached to the same carbon. This compound can be written in a condensed form as, and since there are three CH3 groups on the same central carbon, the condensed structure can also be written as, where the CH3 group is written in bracket with a numeral subscript of 3, indicating that there are three CH3 groups on that particular carbon.